Okay, so here we have our two-dimensional contour map, and we generated a two-dimensional contour map from each layer. Here I've sorted the layers from the smallest, the layer with the smallest footprint, all the way through to the layer with the largest footprint. So that there represents the bottom of the mountain, that there represents the top of the mountain. Okay, with any kind of map or contour map is associated a scale, a map scale. So in this case, if you remember correctly, I said at the very beginning that each centimeter represents 100 meters. And so each contour line here represents 100 meters. And I've captured that, as you can see. So 0 meters, 100 meters, 200, 300, 400, 500, 600, 700. And the very top vertex of the mountain is 800 meters. Okay, so we need to actually capture this on this piece of paper. So I need to say that the map scale for every centimeter is equal to 100 meters, or for every 10 millimeters is equal to 100 meters. Okay, so we need to be able to express this as a ratio. Okay, so typically on a map you will either see it in this form here, or you will see it as a ratio. So the way we do that is, okay, for 1 centimeter equal to 100 meters scenario, we know that 100 centimeters is equal to 1 meter. Therefore, our 1 centimeter equal to 100 meters times 100 centimeters on 1 meter. That's our conversion factor. To convert our 100 meters to centimeters, the meters cancel out, and therefore 100 centimeters is equal to 10,000 centimeters. Now, with the ratio representation, we can ignore the units, and therefore we can write 1 to 10,000 is the ratio. We can do the same in regards to the other unit, millimeters. Whichever one you choose, you will always end up with the same ratio if you've done it correctly. So we also said 10 millimeters is equal to 100 meters. Now we know the conversion from millimeters to meters is 1,000 millimeters is equal to 1 meter. Therefore, we can convert our 100 meters to millimeters, as I've done here. The meters and meters cancel out, and so we end up with 10 millimeters is equal to 100,000 millimeters. Now, whenever we express numbers as a ratio, we always refer to the smallest number, which in this case is 1, the units. So we can cancel 1 0 from that side, 1 0 from that side, and we end up with 1 to 10,000. And you'll notice that is exactly the same as what we have obtained earlier. So no matter which path you take, either use a centimetre to 100 metres scale, or refer to 10 millimetres to 100 metres scale, you'll always end up with 1 to 10,000, 1 to 10,000. Okay, the next stage involves constructing a profile. So I'll be talking about how to construct a profile from a two-dimensional contour map. So it's relatively easy. All you need to know is, once you've established the scale, which we have, you grab your ruler and measure exactly where each contour line intersects in terms of distance from line A and B. So I've drawn a line from this side of the mountain going straight through the middle, through the peak, and to the other side. So point A through to point B. We have a horizontal straight line. So point A to point B. And of course, point A to point B represents, this is the actual base, so this is the base of the mountain, and so it represents from one side to the other side of the mountain. In other words, the width of the mountain, the base of the mountain. Okay, so what we do is grab our ruler, and I'm going to choose to use the millimeter scale so I can get an accurate reading of where each contour line intersects the horizontal line AB. So ensure that we're starting from 0, so point A represents the starting point. So all we need to do now is just read off from the ruler. So starting from 0, so point A is 0. The next contour line, which occurs at an altitude of 100 meters, intersects at 5 millimeters. The next line intersects at approximately 15.5 millimeters, etc. So what we do is take a measurement of where each contour line intersects and tabulate the results. I would suggest to create a table where, first of all, the first column represents the intersection number, and if we go back to our map, let's go back to the map. We know that we should have, so we'll count it together, how many intersections? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So altogether there should be 17 intersecting points. So I'm going to fill in the table accordingly. So the first column represents the number of intersecting points. Okay, the next column, it's a good idea to put in the altitude. Okay, so obviously the first contour line intersecting point, which is point A, occurs at an altitude of 0 meters. So units, meters. Next one occurs at 100 meters, 200 meters, etc. Remember, intersection point 9 represents a peak, and then obviously after the peak we end up going back down, so altitude 700, down 600, 500, 400, 300, 200, 100, and finally 0. So that intersecting point, number 17, represents B, point B, which is on the other side of the mountain, and 9 represents the peak. Okay, the next column will be the distance, the actual distance of the intersecting points that I was showing earlier. Okay. So the first point we said intersection point, which is point A, is obviously, now that's in units millimeters for greater accuracy, 0. The next one occurred at 5, etc. So I'll just put that down on this side here, so I don't need that space. So I've already done this to save time. Okay, so we've established from point A to point B is point B. So from point A to point B is 98 millimeters. So from point A to point B is 98 millimeters. The next column, we need to convert it to the actual distance in meters. So the conversion to meters. We know the scale factor was 10 millimeters, is equivalent to 100 meters, or as a ratio 1 to 10,000. So what we need to do is multiply each number here by 10,000. So the first one is 0, next one is 50,000. Now that's 50,000 millimeters, but we want to express the answer in